Good morning to all of you. I welcome you to this session of PL SQL. In today's session, I'm going to discuss the triggers with you. Triggers are stored programs that are fired by Oracle Engine automatically when some DML statements like insert, update, or delete are executed on the table or some events occur. Okay, so the code which needs to be executed in case of a trigger can be defined as per the requirement. Okay, so trigger is something which automatically executes whenever you are handling the DML statements like insert, update, and delete. Now there are several advantages of using triggers. They provide an alternative way to check integrity. They can also catch the errors in business logic in the database level. With triggers, you don't have to wait to run the scheduled tasks. You can handle those tasks before or after changes being made to the database tables. So basically two types of triggers are there, row triggers and statement level triggers. So I'll explain these in today's session. But before that, let's just discuss the trigger syntax. That is how to create a trigger. So the syntax goes like this. First see on the left side of your screen, create or replace trigger, trigger name. Then when the trigger should fire. So this is the timing. Before, after, or instead of, three options are here. Then delete or insert or update of the columns on table name. Referencing old as old, new as new for each row when condition, and then the code which needs to be executed. So let's understand each one of these things. So first of all, this portion where you are creating the trigger and you have before, after, instead of, delete or insert or update of column on table. This is known as the triggering event, which is going to trigger the trigger. So a triggering event or statement is the SQL statement that will be causing the trigger to be fired. Okay, and a triggering event can be, it could be an insert event, an update event, or a delete event, right? So whenever you're using insert, update, or delete, your trigger may get fired. Next comes the triggering restriction. Okay, so when you are using some condition and that condition returns true, only then your trigger is going to fire. So when we have row triggers, we write this clause for each row, and when we need to specify some condition, we can specify it with the when clause, when condition. So this when condition is there only in case of row triggers. So when you write for each row, only the when condition can come along with that. So they occur at the they occur simultaneously. You need to write both of them together. You cannot write one of them without the other. And then obviously you have the PL SQL block which needs to be executed once you are taking some action after the firing of the trigger. So I'm going to discuss each of these syntax details in shape of some examples with you. Okay. So let's first create a few triggers in today's session. Let us create a trigger on M table which always keeps the inserted or updated values in ename and job columns in uppercase. Okay. So try to understand the problem. Whenever we are inserting or updating values in ename and job columns of the M table, whether you provide lower values in lowercase or sentence case, your trigger will automatically maintain the values in uppercase. That is what the problem is. Okay. So let me just start a SQL session here for you guys. Okay. And let's create a trigger. Say, let me write a script file with the name as trig1. Remember what the problem statement is. The problem is we need to create a trigger which is going to keep the inserted or updated values in ename and job columns in uppercase in the M table. So we have the triggering event as the insert or the update, and the column names are ename and job. Okay, so let's write it here. The syntax. I'm going to write this example now. So create or replace trigger. Say let me keep the name as up trigger. This is the name of the trigger. Okay. So before you can actually enter values, before the values can be actually entered, inserted or updated in the M table, this trigger needs to fire. So before trigger, an insert or update off. What are the columns here? Ename and job. Okay. So before I insert or update something into the ename and job columns of the M table, I'll just match the syntax with you. Okay. On M. Okay. And then because this trigger needs to be fired for each row, so we must write here for each row. Okay. And then I can write something like referencing old as old, new as new. To begin with, I'll take these default names. Okay, I'll explain it to you what they mean actually. Okay, and once finished, then I can begin my PL SQL code. Okay. Now what I need to write here is that the new value of ename should always be, I'll use the upper function here. I'll write it like this. Okay, I'll tell you what it means actually once I finish writing. Same is with the job. So whenever you are inserting or updating a table, you are dealing with the new values which you're going to put either in the way of insert or update into the table. So what this code here suggests is that the new value of ename, whatever it is, it should be first converted into uppercase and then it should be inserted. Similarly, the new value of job should be converted into uppercase and then sent to the table or entered into the table. So I'll save it, okay, and then I will execute it. Okay, so it says invalid trigger specification. Let's see what the error is. Let's see, check the syntax first. Maybe we have referencing old as old, new as new. There's nothing wrong in it. What's wrong in it? Let's just check. Okay, I think the order we have, we have just picked up the incorrect order. I'm sorry about this. It needs to come after this, right? Now it would be okay. So again run it here. Yeah, now the trigger is created. So it is not executed, it is simply created. But now whenever you're going to use this insert or update on your M table, it will keep track that the ename and the job values are in uppercase. So let me just put a insert statement here. So let me insert values into the M table. I'm going to enter the M number, ename and job. Let's say I'm just interested in adding these values. Okay. So I can put it like this, and then M number I can give as 2900, ename I can give as Ajay, and job I can give as salesman. So I'm entering these values, and kindly see that I have given the name and the job in lowercase, right? So it tells you that one row has been created. That means a record has been inserted into the M table. Okay. Now let's see. First I can just set some screen size here. And then I can write select star from EMP. So you can see at the bottom that the record that I've inserted here, 2900, okay, and the name has been automatically converted into uppercase. This has been taken care of by our trigger. So I use this statement here. I specified the values in lowercase, but it has automatically converted it to uppercase. So as soon as you write this insert statement, this trigger, so you've written here that before inserting Okay, so it will convert the name and the job values into uppercase. Okay, so this was the first problem that we discussed. Let's now move to the next problem. Next is now we need to create a trigger, okay, which is fired on deleting a record from the department table. And before deleting this record, it should delete the corresponding information from the employee table, I think. Yes, I'll explain it to you what it means actually. Okay, so let's just see the structures of the emp and the department table. Now, what is the connection here is that in the department table there is a department number column, okay, which is the primary key, and this column also occurs in the emp table here, where it is a foreign key. So, whatever values for department number are there in the department table, except those values, no other value can be there in the emp table. Okay, so for example, if I show you the department table contents, you can see that there are 5 departments: 10, 20, 30, 40, 50. Okay, so in my emp table, if we see the emp table contents, you can only have departments which are there in department table. So we can have 10, 20, 30, 40, 50. Only these department numbers can be there in the emp table. Okay, you can see there only these departments are there, or we can have null values also for department number in emp table. Now what I'm suggesting here is, let me just show you the connection here. If I just insert another record into my emp table and I specify the department number as 70. Now remember, there is no department number 70 in the department table. You can see here there is no 70 number department. So since this is the parent, this is the primary key, and here in the emp table this is the child key. Okay, so no value, if a value 70 is not present here, it cannot be inserted into the emp table. We can see it here now. I'm going to insert it and just see, press enter here. Okay, so you see that the primary key constraint has been violated. Okay, or rather before that it has picked up this 2900 error, because that's it. Let's me put it at 79. Let me put this number here. So now you will say, because now we have given a unique employee here. Okay, so it will tell you that the 70 number is not present in department table. So it is saying that the department number table is not having this value 70. So no parent key is there. So this record cannot be inserted. Now, why have I explained this thing to you? When we are working with this example here, okay, when we are working with this example here, if you delete a record from the department table, okay, let's say I delete this record, say 10, department number 10, let's say the company is closing this department. So automatically all the occurrences of department number 10 in the emp table should be removed. Okay, fine. So that is what our trigger is going to do. That if you delete something from the department table, okay, then the corresponding department number would be deleted from the emp table. Okay, so let's create that trigger now. Let's create that trigger. Okay, I'm going to write the trigger here. Create or replace trigger. Say we can write, give some name, DPT. Okay, department. Okay, so now when this should fire, before you delete something from the department table. So before delete on department. So this is based on a deletion of a record. So no columns. Whenever you delete a record from the department table, this trigger should fire. So before delete on department. Okay, so referencing, say old as XYZ, I'll change it now. Okay, and new as DEF. I'm going to change the names here. So I'll refer to the old values of data with the word XYZ and the new values of data with the word DEF. Okay, this I'm going to show you so that you can understand. Okay, for each row. Okay, and then you write the code. Okay, so begin. Now what your code should do, that before something is deleted from department table, the corresponding record from the M table should be deleted. So it should be something like delete from M, where department number is equal to, so here you need to give, because there is no new value, we are going to delete something, some existing value, so we need to write the old value. So here we can write the XYZ dot department number. I hope you understood what is this referencing aliases. So XYZ dot department number. Okay, and then you can print a message here that how many records have been deleted. So did we miss this? You can use your implicit cursor to check for this. You can write here number of rows deleted are, okay, number of rows deleted are. Then you can use this SQL percentage row count. This is not case sensitive, but I am writing it in uppercase just to distinguish it from the message. So it will tell you. Now what happens with this implicit cursor is that it is also executed as soon as you use some insert, delete or update. So whenever you're using this delete, and this delete is deleting say 4 records, so this SQL percentage row count is going to return 4. That is what the meaning here is. Okay, and then you can write an end here. Okay, so what I'm doing, that whenever somebody tries to delete a row from department table, okay, before that what it does, it deletes the corresponding rows from the M table. And which rows? So whatever department number is to be deleted, whatever department number you will mention in your delete statement, that department number would be taken here. And I'm referring the old values with the alias XYZ, so I need to write it as colon XYZ dot department. Okay, so let's just compile this here. So I'm going to compile this. Let's hope that all is good. Yeah, so trigger is created here, right? And now see, if I delete, let me just first check select star from department, or rather select star from M, where department number I'm going to delete department number 10. I'll be deleting department number 10 from the department table. So there are 3 occurrences of department number 10 in the M table. So if I write a statement here, if I write this statement, so this is the old value, okay, this is the existing value of department number 10. This value here is picked up by this XYZ dot department number, because you are referring to the old value with the alias XYZ. Okay, and if I do this delete, before this delete, this deletion from M table will take for department number 10, and all these 3 rows like Clark, King and Miller, these occurrences records won't be there. So if I write it like this, so it simply tells you 1 row is deleted from department table. But if you check this query, it will return no rows, because now these records have been deleted from M table, all because of your check put in that trigger. Like you mentioned this thing there, that before we delete something from department, the corresponding information from the M table should be deleted. Okay, so that's all for this video. In my next video, I'll be discussing some more problems, more complex problems on triggers with you.